Hello class, this is problem 6 from exercise 8D, problem 6. Problem 6. Okay, which is the following. They're giving you two probabilities. The probability of an event A, which is this much, the probability of an event B, which is this much, and also the probability of the union of those events, which is 0.5. And they want you to find this probability and this other probability. So in here I have written what we know. This is the information we know. We know this, and we know this. And they want me to find the probability of A and B the probability of A prime or B. So how do I find this? This probability, I'm going to use this formula. Okay, by now you should have memorized this one already. Why do I write it down? Because I know that I have this, which is right here. I know this, which is right here. And I know this, which is right about here. And therefore, I can isolate this information, which is the thing that they're asking me, right, from that equation. I have the substitutions in here, and finally, when you isolate this probability, you should be getting 0.1. So that's the first question. It's right here, 0.1. And then B, the probability of A prime or B. I'm gonna use once again the formula for this or event, an event or another event. That's the formula. It's basically this one, right? Okay, so I have this already, P of A prime. Why? Because I know P of A, which is 0.2, and therefore P of A prime is gonna be 0.8, which I wrote in here. P of B, we know it, 0.4, there it is. And the thing I don't have at this moment is the probability of A prime and B, the probability of the intersection. So let's see, what is this probability? How can I get it? Once again, you cannot do this. You cannot do it unless you know that these two events are independent. If you don't know that, you cannot use this, and you need to go through another direction or another route. So you can use the Venn diagram. This is the event A, this is the event B, and let's see. I'm going to highlight A prime in yellow. Everything that is in yellow, that's A prime. And B is everything that is in blue. Okay? So the probability of the intersection is where both events coincide, which is basically all of this area. This white area, all of this that I'm highlighting right now. This is the probability of A prime and B, all of this thing. And reasoning geometrically, we can see that this white area, the white area, is equal to the probability of B, which is all of the circle, minus this little bit in here, which is the probability of A and B, the intersection of A and B. And therefore, we have this and we have this too, right? Look, so the probability of B, that's 0.4 minus this probability, which is 0.1, and therefore the white area is going to be 0.3. And remember, the white area represents this probability. So let me just substitute that in here, and that's it. We can find the probability of A prime or B, which is going to be 0.9. Yes, that's right. Okay, so that is the first of these problems that I'm going to be solving for you. I'm gonna make a pause in every single problem to copy some stuff, and then I'm gonna explain maybe a few things. So let's continue. So exercise 8D, problem 7, which is this one. They're giving me this information. Basically, I have copied everything that is in here into in here, right here. They're giving me two events A and B, and they are giving me the probability of event A, the probability of event B, and also they tell me that the probability of A or B is equal to 3 times the probability of A and B. That's all they're telling me. They're telling me these three pieces of information. The first question is this: find the probability of A or B. So this is the question. Once again, what do I use? I use the main formula, which is this one. Okay, the same as always. And what I'm gonna do is this, guys. I'm gonna use this fact. I'm gonna use the fact that the probability of A or B is equal to 3 times the probability of A and B. And basically, I replace that in there. Can you see? I substituted this for this because of this. And then probability of A, we have it. The probability of B, we have it. We substitute. And this we keep the same. We keep the same, like that. Okay, now look at this equation. We have the same thing, the same number, which is this one, in both sides. And therefore we can solve it. We just add this to both sides in order to have this. We add these two numbers to get 9 over 16, and the rest is pure arithmetic. This is going to be equal to 9 over 64. Okay, but this is not the question that they're asking me. They are not asking me the probability of A and B. They're asking me the probability of A or B. But now that I have this, I just go back to this information, right? I just can input this number in here. Can you see? And that's how I'm gonna be getting the probability of A or B, which is right about here. That's all I did in here. Check it out. You have to pause the video a lot of times in order to check what I'm doing. And this is the result for this question. Then the question B, find the probability of the complement of A or B, which should be written like this, not like this. This is incorrect notation. So find the probability of the complement of A or B. Now by using our good old formula, the probability of A complement is equal to 1 minus the probability of the, the normal event. I'm using this in order to write this. Check it out, right? Okay, so then let's continue. This is the same as this, same as this. I already have this probability, which is 9 over, no, what am I doing? Let me, this is wrong. I copied this incorrectly. This number should be 27 over 64 because it's the probability of A or B. Yes, it's gonna be this number. Therefore, this is also wrong. And this number should be, let me check that out, 37. 37 over 64. So that is the answer for the second question, right here. Okay, and then question C, the probability of A and B prime. I want to know this. So I'm going to use my Venn diagram once again. A is the yellow area. B prime is the blue area. B prime is everything that is not B. So everything that goes outside B. That's B prime. All of this blue stuff. and we're talking about the intersection. So that's where both areas, yellow and blue, intersect. And as you can see, they intersect right in right here in all of this, in all of this. So this is the area that I'm looking for. If I know this area, then I know this value. So how much is this area? Well, uh, reasoning in a geometrical way, we can see that this area, this white area, is nothing but the probability of A minus the probability of this intersection, right? And we already have that intersection, which is this much. So this is going to be equal to P of A, which is 3 over 16, minus this number, which is 9 over 64. And we are done. Whatever this number is, that is the answer for letter C. And that's how this problem ends. Once again, let me pause. I'm going to come back with you in a moment. Exercise 8F, problem number 4, which is this one, the one about Toby, and which is, I don't know, a kid playing this game, Come and Go. And this game involves having two, well, no, having one die and rolling it twice. Twice. And you have this, all of this context. Please, if you want, stop the video, read it, and let's continue. So this guy has this die. He's gonna roll twice, and as you know by now, the sample space is gonna be 1, 1, 1, 2, all the way through 6, 6. So we're gonna have 36 individual outcomes in the sample space. Why did I put this cross in here? What does it mean? It basically represents the information that you're given here. If he rolls a 1, he goes forward. If he goes a 3, he goes backward. If he rolls a 2, goes right. If he rolls a 4, goes left. And if he rolls 5 or 6, he stays where he is, which is this point. So that's what this cross means. Okay, so that's the game. This is the sample space that we can obtain by rolling the die twice. And that's the whole context. Now let's look at the questions. The question A is, find the probability that he stays. No. Oh, no, yeah, that's right. Find the probability that he is at the same point where he started after rolling the die twice. Okay, so what are all the favorable outcomes to this event A? I'm calling it event A. This stuff is event A for me. So I want the probability of event A. The favorable outcomes are all of these. 1, 3, because if he rolls 1, he goes forward, and then if he rolls a 3, he goes backward, and he's going to stay at the end of this process, he's going to stay in the same position as where he started. The same with 3, 1, like 3 and then 1, or 2, 4, 2, 4, and you get the idea, right? And also when he rolls either 5 or 6 in any combination, he's going to stay in the same position according to the instructions. So we have eight favorable outcomes to this event A, and therefore by following the simple, the most simplistic way of the probability, which is favorable outcomes over the total number of outcomes, which are 36. Therefore, we can say safely that the probability of A is going to be 8 over 36. That's it. That's it. Next, what is the probability of B? He is exactly 2 meters away from his starting point. Well, the favorable outcomes for this event B are all of these four. 1, 1. So basically, if he gets 2 ones, he's going to go like 1 unit and then another unit. Or if he rolls 2 times, he's going to go 1 unit and then another unit. So he's gonna be 2 meters from the starting position, and That's how it is. So once again, therefore the probability of B is the number of favorable outcomes, which is 4, over the total number of outcomes, which is 36. That's it. We can simplify this, but that's the number. And C, what is the probability that he is more than 1 but less than 2 meters away from his starting point? Well, that happens when he rolls, for example, 2,1. So if he rolls a 2, he goes 1 unit in this direction. And then if he rolls a 1, he goes forward 1 unit. So 1 unit, 1 unit. This is the starting position. This is the final position. And as you know by Pythagoras, this is going to be the square root of 2, which is more than 1, but less than 2, according to this thing. So 2,1 is a favorable outcome, which is going this way and then this way, or 1,2, which is going this way and then this way, or 4,1, which is this and this, or 1,4, which is this and this. You see, this is one outcome, this is another outcome. And so basically you're gonna have two possibilities for each quadrant. 2 plus 2 plus 2 plus 2. So how many favorable outcomes do we have? We have 8 favorable outcomes. Once again, out of 36, thus the probability of C is going to be 8 over 36. And that finishes the problem. Exercise 8G, problem number 4, which is this one right here. And what do we have? We have three events, A, B, and C are such that A and B are mutually exclusive, and we have this info, this info, this info, and this info. So we have 5 pieces of information, guys. First, we have this sentence right here. A and B are mutually exclusive. And here in my section for the data, I wrote that A and B are mutually exclusive. That is completely equivalent to saying this. Okay? We know this, or we know that another way to say this is that the probability of A and B is 0. Okay, remember that if you draw a Venn diagram for two mutually exclusive events, they should be looking like this. They should be completely disjointed in this way. They should not overlap, because if two events look like this, they mean that that means that they can occur at the same time, which is in this section, right? So in this case, these are not mutually exclusive, but these are. And as you can see, when this happens, then the probability of the intersection of both events is 0. So either this or this tells you that A and B are mutually exclusive. These are mathematical expressions of this sentence. Let me erase this. Okay, and then we have the other 4 pieces of information. This, and this. So let's tackle the questions. Calculate the probability of B and the probability of B and C. I have the questions right here, and let's get started. First, I wrote this formula, okay, and then I'm gonna substitute this for this because we have it. I'm gonna substitute this for this and this for this, and remember this is gonna be 0 according to this. Let me write it down. -0, because of what we established a few seconds ago. So that's it. This equation already allows you to calculate the probability of B, and that's going to be 0.2. So that answers this part of the question. So this is done. And now calculate the probability of B and C. So let's do it. First, once again, let me use the same formula for the probability of B or C. That's equal to all of this. And let me substitute this for this because I have it. And the probability of B was recently obtained, so I can write it down. The probability of C I was given, and that's it, right? The only thing that remains is the probability of B and C, and I can isolate from this equation in order to come to this conclusion, 0.16, and that takes care of this one. Okay, now question B, determine whether B and C are independent. Okay, so in order to determine whether two events are independent, we should have, remember, I'm gonna do that in blue over here. If B and C are independent, we must have necessarily this. If they are independent, this must be true. And if this is not true, then that means that B and C are not independent. So let's calculate this. It's right here. And let's calculate this product of these two probabilities, which is over here. And I just look at both of them. They're not equal, right? So since this probability, which is this one, is not equal to this product, which is this, then I can conclude that B and C are not independent. So that takes care of this other question. And that finishes this problem. Exercise 8G, problem 7, which is this one right here. Once again, what information are they giving me? They're giving me this, which is equal to this, which is equal to 0.6. And they are also giving me the probability of E and F, which is 0.24. That's it. That's all the information they're giving me about events E and F. Okay. So the first question they're asking me, write down the probability of E. That's straightforward. That's going to be 0.4. Why? Because I know that the probability of E complement is 0.6. So that's immediate, right? Okay. So that solves this problem. And then question B, explain how you know E and F are independent and how you know that they are not mutually exclusive. So first, how do I know that this and this are independent? Well, I know because this equation is satisfied for E and F. That is, the probability of their intersection is equal to the product of their probabilities. The probability of the intersection is 0.24 as specified right here. And then the probability of E, we just found it. The probability of F is given here. And that's it, right? This is true. So this equation is true. Therefore, E and F are independent. Therefore, they are independent. Done. Now the second option. Explain how you know that E and F are not mutually exclusive. How can I know that? Well, they are not mutually exclusive because the probability of the intersection is different than zero. Different than zero. Once again, according to this, the probability of the intersection is different than zero. And when you have remember guys, when you let me do it right here. When you have mutually exclusive events, their Venn diagram looks like this. They are completely separated events, because that means that if this happens, then this doesn't. And if this happens, then this doesn't. So this is the Venn diagram for two events E and F, which are mutually exclusive. Mutually exclusive. And that this diagram tells you right away that the probability of the intersection should be zero for mutually exclusive events. So, if this is not true, if you have that the probability of the intersection of two events is not zero, that tells you that they are not mutually exclusive events. So that's what we have in here. The probability of the intersection of E and F is not zero, therefore it follows that they are not mutually exclusive events. And that takes care of this question. Perfect. Question C. Find the probability of E or F prime. In other words, the probability of the union of E and F prime. That's equal to, who knows? Okay, so let's write the formula for the probability of a union, which is, as you may know by now, it's equal to this. Okay, and let's substitute. We have P of E, which is 0.4. We have P of F prime, which is 0.4, because I know this, and from here I can get that the probability of F prime is 0.4. So I know this, and I obtained this value, the probability of E and F prime, which is 0.16, and I obtained it in this little corner. Let me tell you how I obtained this value. So first of all, I drew the Venn diagram for E and F. Okay, so this yellow highlight, this represents the probability of E and F prime. This This is where E happens and also F prime happens at the same time, which is what this means, right? And so if I can get this yellow area, then I'm gonna be getting this probability. So visually speaking, how much is this area? Well, that's equal to the area of E minus the area of this intersection. The probability of E minus the probability of the intersection of E and F, which is this little bit. And I already have these two values. The P of E is right here, 0.4, and P of E and F is right here, 0.24. Therefore, I can get this probability as 0.16. You see? And then I just I bring this, and I put it right here, which is this. And that's it. The probability of E or F prime is equal to this plus this minus this, which is 0.64, and that closes this problem. Exercise 8G, problem 9, which is this one. In this problem, they're telling you that A and B are independent events, and they're giving you the probabilities of each of those events. So that information is condensed right here. Remember, when we say that A and B are independent, we are basically saying this. This phrase and this equation, they say the same thing. That's why I'm writing this equivalent symbol. This is equivalent to this. And we also have these other two uh, pieces of information. Okay, so first question, the probability of A and B. It's equal to this. And this is quite simple, guys. Just read it. Make just stop the video and read the algebra. It's pretty simple. Okay, and then the probability of a and b prime. I'm sorry. No, yeah, I was right. The probability of a and b prime. So that's the same. If I know that a and b are independent, then I also know that a and b prime are independent. If you remember that was a question I asked you to think about. If you know that a and b are independent, then does that mean that a and b prime are independent? The answer is yes. All the combinations. In fact, if you know that this is true, then this is also true, and this is also true. A prime and b are independent, and also a prime and b prime are independent. So all the possible combinations between a, b, and their complements, they are all independent. So these and these are independent, therefore I can write this formula. I can substitute b of a is this, b of b prime is this, and thus I can find the solution for the probability of a and b prime. And finally, the probability of a or b prime. Once again, by now you should have memorized this, right? The formula for the union. And then I just substitute, guys. It's a substitution, and I encountered this solution. Pretty simple problem. Pretty simple problem. So that's it. Okay, so this is problem, I'm sorry, this is exercise 8H, problem 1. This one. I want you to stop the video, and read it once, please. I'm gonna assume that you already did that. So let's continue. What is the information that I'm given? I'm given this. You have 27 students in a class. Okay, fine. And then 15 of them take film, 20 take theater, 4 do not take neither film nor theater, and that's it. That's all the information that I was given. And then I'm asked a series of questions. Okay, the first thing I did, guys, was drawing the Venn diagram for this situation. This is the Venn diagram. All the rectangle represents all the class, all the students in this class. So I know that inside this rectangle I have 27 students. Okay, so what does this circle mean? The circle means the students that take film. All this circle means the students that take theater. This bit in here represents the students that take both film and theater. And what is outside the circles, which is all of this area, represents the students that take neither film nor theater. So I already know how many students I have outside. I have 4. Now, I have 15 that take film. So in all of this circle, guys, in all of these circles, that means between this part and this part, I should have 15 students. Maybe there are 10 here and maybe 5, or maybe 11 and 4, or maybe 9 in this part and 6 in here. So how do you know? How do you decide how much in here and how many I'm sorry, how many here and how many in here? How do you break that number 15? What is the approach to follow? Well, the approach is this, guys. I'm gonna tell you one possible approach. I mean, you can do it just by inspection, but if you wanna have like a more recent out uh, method, you can do this. So how many students am I gonna have in this first section? I'm gonna have A students. I don't know how many I don't know what A is at this moment. I just know that they are A students. And in here, in this section, I'm going to have B students. And in this other section, I'm going to have C students. By now, all of these three things are just variables. Variables. But what do I know about these three variables? What do I know? What equations relate A, B, and C? Can I write some equations relating these three variables? Yes, we can. Yes, we can. I know that 15 students take Phil, so that means that A plus B should be 15, right? Because I have 15 students inside this circle, and this circle is composed of both A plus B. So this must be true. 20 take Phil, so I'm sorry, 20 take theater. So this is theater, so that means that B plus C must be 20. Perfect. What else do I know? I also know another equation that relates both, the three variables, A plus B plus C. A plus B plus C must be equal to 23. Why 23? Because we have 27 students in the class, 27. And I know that 4 of them are outside the circles. You see, 4 live in this part. So how many should live in all of this? In both in this section inside the circles? Well, there must be 23. A plus B plus C must be 23. And that's it, guys. With these three equations, you can actually get the number A, the number B, and the number C by playing with these equations algebraically. Okay, for example, look, B plus C equals 20, and I have B plus C in here. So I can write A plus B plus C, which is 20, equals 23. So that's it. You see, I already found that A equals 3. Period. It's very simple. You see, A equals 3. And if this is 3, how much is B? B must be 12. And if B is 12, how much must C be? Well, 12 plus 8 is going to be 20, right? So that's it. A equals 3, B 12, and C 8. And that's how you can have a more methodical approach to finding these three values. So this is 3, and this is 12, and this is 8. And now that you have done this, you are prepared to solve any of these questions. For example, question A. By the way, let me check if I think I did this wrong. Let me make a pause. Let me check this. Let me check if I did this correct. Wait a second. Yes, it's correct. All of this is correct as far as I can see. Okay, and then you are, like I was telling you, you are prepared to solve any of these questions. Question A, how many students take both subjects? Well, 12. It's all of these guys. So, question A, 12 students. That's the answer. And then B, one person is chosen at random from this class. Find the probability that the person, I, takes theater but not film. Theater but not film. So it's all of these guys. It's these 8 people. These 8 people take theater but not film. So 8 favorable outcomes. The probability of this event, I'm gonna call it event I, just like the question. The probability of that event is 8 over the number of students, which is 27. That's it. Second, what is the probability that the person takes at least one of the two subjects? At least one. So all the people inside here, guys, all these 8 people, all these 12 people, and all these 3 people take at least one subject. You see, these take only one, these take only one, and all of these people take both. But all of them, we can say that they take at least one of the two subjects. So all of these people are favorable to this event. So the probability of 2 is equal to all of these people, which is 23, over the number of students, which is 27. And the third question, what is the probability that the person takes theater given that they take film? Okay, that sounds a little more complicated. Let's see. So, what is the probability of this event that I'm calling event 3? Maybe not a very good name, but anyway. So, what is the probability that they take theater given that they take film? So, we already know that this has happened given that they take film. We know that the person that I chose, this person, I know that this person takes film. So remember, what's going to happen? What's going to happen is that the sample space is going to collapse. It's going to be reduced. And now my sample space will only be this section right here. Okay? Once I know this fact, that the person that I chose takes film, then this is my new sample space. All of this in yellow. And I don't care about the rest that is outside this yellow space. And the question is asking me, what is the probability that this person takes theater? So what is the probability that this person is right here once I know this? So the way we can do that is this. What is this area? This area is 12, right? And well, not 12, it's 12 over 27. That is the probability of this area. So the probability that the person is right here is 12 over 27, and that needs to be divided over this whole area, which is 15 over 27. Remember, why am I dividing over 27? Because the it must be in relation to the whole sample space. In the end, it doesn't matter, as you can see, because these and these are going to be canceled, and so the end result is 12 over 15, or 4 over 5. Yeah, so basically this 4/5 is the ratio of this area to this area in total. Okay, the ratio of this area to this area, which is 12 over 15, which makes sense, right? Because in here all of this circle is 15 people in total, 15, and there are 12 in here and 3 in here. Don't pay attention to the fact that I drew it differently. I mean, this should be much less than this because there are more people in here, but it doesn't matter. I've told you enough times that a drawing like this is not it's just a visual prompter. Okay, it's an aid. That's all it is, guys. So this is the result for the number 3. 4 over 5, which is the ratio of this area, once again, is the ratio of this area to all of this area of this circle. And that takes care of this first problem. Okay, and then exercise 8 H, problem number 6. This one. Your neighbor has 2 children. You learn that he has a son, Samuel. What is the probability that Samuel's sibling is a brother? Okay. So, when a couple has 2 children, guys, what is the sample space? What are all the possibilities for these 2 children? Well, we can have that the first child is a girl and the second is a girl, or we can have that the first is a girl and the second is a boy, or boy girl, or boy boy. We have only these 4 possible outcomes of this experiment, of the experiment of a couple having 2 children. Okay, we can have only one of these 4. Okay, and we know that all of these outcomes are equally likely because the probability of having either boy or girl uh, is the same according to biology. It's approximately the same. So this, and these outcomes are equally likely. Okay, then what? What do we know? We know, we learn that one of the children is a boy, which is Samuel. Okay, and that reduces automatically the sample space because now we know that either this or this or this has happened. Why? Because we know that the couple has a son. So either this happened or this happened or this happened. We automatically discard this possibility, and that's why my sample space gets reduced. My new sample space, which I may call S prime. No, let me call it something else. S bar. This is the new sample space. The new sample space is girl boy, boy girl, and boy boy. Okay? And basically the question is this: what is the probability that Samuel's sibling is a brother? In other words, what is the probability that both children both children are male? That's it, guys. So if you look at the sample space, the only outcome in which both children are male is this one, boy and boy. And since this and this and this are equally likely, and we have only one favorable outcome for this question, for this event, that both children are male, then, I mean, quite clearly, the probability of this event, which I may call event A, the probability that Samuel's sibling is a brother, is the same as the probability of having this, which is 1 out of 3. And that's it, guys. Not really complicated. Okay? 1/3. Although this is a classic problem, that's why they put here. Hint, this is not as obvious as it might initially seem. Because a lot of people go with, like, I don't know, they go with the first thing that they think, and they answer this one wrong. But this is the solution. It's 1/3. So that takes care of this problem.